In our lesson today, we're going to learn about square roots and cube roots. And we're going to start off with square roots. A square root is the inverse operation of squaring a number. Said another way, we want to know which number multiplied by itself is equal to the original number. Okay, the symbol for a square root will look like this, where x is a non-negative value. Okay, the number that's underneath this symbol here can only be a positive number or 0. And example number 1 asks, why is an exponent of 2 called squaring? Well, this term comes from finding the area of squares. All right, we all know from a picture of a square that all four sides have the same measurement on a square. And if you were looking for the area of a square, you would use the formula area equals base times height. Since the base and the height have the same dimensions, in this example, I would say that base times height, we're just going to do 4 times 4. Well, 4 times 4, if it's repeated multiplication, you can write with a single base of 4 raised to the second power, where again, the exponent tells you how many copies of the base you're going to multiply together. So area equals base times height, which is 4 times 4, or in this case, 4 to the second power, 4 squared, which means that the area here is equal to 16 square units. Okay, so whatever the units happen to be in this example, we will square those. If I were to tell you the area of the square, you would be able to tell me what the side lengths have to be. In this case, since the area is 16 units squared, the side lengths have to be 4 units each. Finding a square root, again, is the inverse of squaring a number. In other terms, if you are provided with the area of a square, then you can determine the length of each side of the square. Okay, so in this example, all right, since the area is equal to 16, if I wanted to figure out what the side lengths were, I would have to take the square root of 16, and the square root of 16 is equal to 4, all right, because 4 times 4 equals 16. All right, what number did I multiply by itself in order to get 16? Well, that number was 4, so the square root of 16 is equal to 4. Now that we have a basic idea of square roots, our focus today is going to be on approximating square roots. When the square root of a number is a whole number, this number is called a perfect square. Perfect square. All right, in the example that we did above right here, all right, when I took the square root of 16, I got a whole number of 4. That means the number that I took the square root of, in this case 16, is called a perfect square. All right, so 16 is a perfect square because, again, when I take its square root, I get a whole number. Now, is every number a perfect square? Well, of course not. No, not every number is a perfect square. Many numbers are non-perfect squares because the square root of that number is not a whole value. Take, for example, the square root of 3 and the square root of 7. If I were to use my calculator and type in the square root of 3, second x squared of 3, there we go, square root of 3. Well, notice that I get this long decimal. In fact, let's write those digits down. 1 and 732,050,808. Okay, what about square root of 7? Square root of 7. And again, I get this other long decimal here, 2 and 6,457,51311. These values are definitely not whole values. Okay, so if I take the square root and I get a number that's not a whole value, the number underneath of the square root symbol is not a perfect square. How would you describe these decimals? Okay, well, these decimals seem that they're going on forever and they don't seem to be repeating in a specific pattern. So I would call them non-terminating and non-repeating. Okay, these decimals are non-terminating and non-repeating. They go on forever without repeating in a pattern. That means that the square root of a non-perfect square is an irrational number. Remember that irrational numbers are decimals that are non-terminating and non-repeating. Anytime you take the square root of a number that's not a perfect square, you're going to get a non-terminating and non-repeating decimal. Example 2 asks between which two integers is the square root of 5? And then they also want to know which integer is square root of 5 closest to. All right, well, 5 itself is not a perfect square. If I were to take the square root of 5, I would get a non-terminating, non-repeating decimal, better known as an irrational number. In order to figure out the two integers that the square root of 5 is in between, what I'm going to do is try to figure out what are the perfect squares that 5 is between. Okay, so 5 is in between which two perfect squares? Well, in class, we're going to be filling out a perfect squares chart, which is going to look something like this. This is my completed perfect squares chart. All of the numbers in this column are perfect squares, like 1, 4, 9, 16, 25, 36, 49, etc. Okay, these are the list of perfect squares. I want to find the perfect squares that 5 is between. And looking at my list up here, I can see that 5 is between the numbers of 4 and 9. 4 is a perfect square because 2 times 2 is 4. 9 is a perfect square because 3 times 3 is 9. 5 is in between 4 and 9. So I can say that 5 is in between 4 and 9, which again are perfect squares. So if I were to take the square root of 5, then I would have to take the square root of my other numbers as well. And that means that the square root of 5 is going to be in between the square root of 4, which is 2, and the square root of 9, which is 3. All right, the square root of 5 is in between 2 and 3. Now I want to know which of these is it going to be closer to? Okay, is square root of 5 closer to 2 or square root of 5 closer to 3? Well, in order to answer that question, we're again going to look at the perfect squares of 4 and 9. Is 5 closer to 4 or closer to 9? Well, 5 is only 1 away from 4, but 5 is 4 away from 9. Therefore, 5 is closer to 4, so the square root of 5 is closer to the square root of 4, which is 2. Square root of 5 is between 2 and 3, but it's closer to 2. All right, let's try that again with a different example. Between which two integers is the square root of 76? Which integer is the square root of 76 closest to? So just like I did before, I have to figure out 76, that's my number underneath the square root symbol. If I took the square root of that number, I would again get an irrational number, all right, which is a non-terminating, non-repeating decimal. But which perfect squares is 76 in between? So if I remember from my list here, okay, here's my list of my perfect squares here in this column. All right, 76 is going to be in between 64 and 81. These two numbers are perfect squares. 8 times 8 is 64, 9 times 9 is 81. 76 is between 64 and 81. So 64 is less than 76, 76 is less than 81. Now, if I took the square root of 76, I would have to take the square root of the other two numbers. So the square root of 76 is between the square root of 64, which is 8, because 8 times 8 is 64, and the square root of 81, which is 9, because 9 times 9 is 81. The square root of 76 is between 8 and 9, but closer to which of those? Okay, so is it closer to 8 or closer to 9? Well, again, look at the perfect squares of 64 and 81. 64 and 76 are 12 apart. 76 and 81 are 5 apart. So square root of 76 is closer to the square root of 81, which is 9. Square root of 76 is between 8 and 9, but closer to 9. In our next example, we want to know between which two integers is the square root of 221. So again, when I take the square root of 221, I'm going to get an irrational number, a non-terminating, non-repeating decimal, because 221 is not a perfect square. What I'm going to do is figure out the perfect squares that 221 is in between. Okay, so again, if I look at my list of my perfect squares, all right, square root of 221 is between which two perfect squares? All right, well, here's my list of perfect squares in this second column right here again. All right, 221 is going to be between 196 and 225. These two numbers are perfect squares. All right, 221 is between 196 and 225. 196 is less than 221. 221 is less than 225. Now, if I take the square roots of the numbers, all right, that means the square root of 221 has to be between the square root of 196, which is 14. 14 times 14 is 196. And also square root of 225, which is 15. 15 times 15 is 225. The square root of 221 is between 14 and 15. Okay, and then in our example underneath, which integer is square root of 177 closest to? Again, 177 is not a perfect square, so I'm going to find the perfect squares that 177 is in between. And looking back at my list of perfect squares again, 177 is going to be between 169 and 196. These two numbers are perfect squares. 169 and 196. That means now if I take the square root of 177, I'm going to be between the square root of 169 and the square root of 196. So the square root of 177 is between the square root of 169, which is 13, and the square root of 196, which is 14. Now, is square root of 177 closer to 13 or 14? Well, again, go back and look at the perfect squares of 169 and 196. 169 and 177 are 8 apart. 177 and 196 are 19 apart. So the square root of 177 is closer to the square root of 169, which is equal to 13. The square root of 177 is closest to 13. In our next example, they want us to solve for x in the equation x squared equals 100. Okay, so right now x is being squared and it's equal to the value of 100. And in order to get the value of x, what we would need to do is take the square root of x squared. Remember that taking the square root is the inverse of squaring a number. So if I had x squared there to figure out the value of x, I would need to do the square root of x squared, which means on the other side, because this is an equation, I also need to do the square root of 100. Remember, what you do on one side of the equation, you need to do on the other side of the equation. All right, so I have to ask myself, what number multiplied by itself would be equal to 100? Well, that's a pretty easy one. I know that that value would be 10 because 10 times 10 equals 100. So 10 squared equals 100. All right, that means that the square root of 100 is equal to 10. But this isn't the only answer, okay? In fact, if we think about it, we could also say that negative 10 multiplied by negative 10 is also 100. A negative times a negative, remember, is a positive number. So negative 10 squared is also equal to 100, which means to this example, there are two answers. X can equal 10, but X can also equal negative 10. To show that it could be either positive or negative, we write the symbol plus or minus. Plus or minus. X can equal plus or minus 10. Okay? All equations of the form x squared equals p, where p is some positive number, they have two solutions. a positive and a negative one that have the same absolute value. In this example, positive 10 and negative 10 are the two answers. Both of those numbers have the same absolute value. In our next two examples, we're going to see if we can figure out what the value of x is in the equation. In this first example, x squared equals 121. For us to figure out what the value of x is, we're going to have to take the square root of x squared, and then we'll also have to take the square root of 121. On the left-hand side, the square root of x squared is x, and on the right side, the square root of 121 is 11, but it can be positive or negative. So we're going to write plus or minus 11. So x could be equal to 11 because 11 times 11 is 121, or x could be negative 11 because negative 11 times negative 11 is also 121. In this example, 2x squared is equal to 50. Again, we want to try to figure out what is the value of x that's going to make this true. Okay, before we can do a square root or anything like that, though, notice it says 2x squared. I just want 1x squared. So what I'm going to do first on each side, I'm going to divide by 2. 2x squared divided by 2 is going to be the x squared that we need. And on the right-hand side, 50 divided by 2 is 25. So now it says x squared equals 25. If we now do the square root on each side, this will give us the value of x. The square root of x squared is x, and the square root of 25, again, is positive or negative 5. So x could equal 5 because 5 times 5 is 25, or x could be equal to negative 5 because negative 5 times negative 5 is also 25. Now that we have a good idea of square roots, we're going to move on to cube roots. Just as with square roots, cube roots are the inverse of cubing a number. We are asking what number cubed, or meaning to the third power, is equal to the original number. The term cube comes from finding the volume of a cube. If a is any non-negative number, then the cube root of a is shown by this symbol right here. It looks very similar to a square root symbol, except there's a little 3 right there, which is indicating that we want the cube root. All right, so that's the symbol for a cube root, and it's the positive number that when cubed or multiplied by itself 3 times results in the value of a. Notice that a cube root does not have two answers. It's not positive a and negative a, it's only positive a. There are not positive and negative cube roots. Each cube root only has one real number solution. In example 4, they want us to evaluate each cube root and justify the answer with a product. So in question A, what's the cubed root of 64? Okay, well, just like with square roots, we had a chart that we were able to find with our cube roots on it. I want to know what's the cube root of 64. And so if I look at my chart here of my cube roots, okay, I'm looking for 64 in this column right here, and I see 64 right here. The cubed root of 64 is equal to 4. The cubed root of 64 equals 4. Justify your answer with a product. Well, that means that 4 times 4 times 4, all right, the number itself multiplied 3 times is equal to 64. 4 times 4 is 16, and 16 times 4 is 64. So 4 cubed is equal to 64. All right, letter B asks, what is the cubed root of 8? Well, if I look at my chart, again, the cubed root of 8 is going to be equal to 2. And again, I'll justify that with a product, 2 times 2 times 2. All right, if I do 2 times 2, that gives me 4, and 4 times 2 gives me 8. So 2 to the third power, or 2 cubed, is equal to 8. So the cubed root of 8 has to be equal to 2. Finally, in letter C, the cubed root of 1,000, and that's going to be equal to 10. My product would say 10 times 10 times 10. 10 times 10 is 100, and 100 times 10 is 1,000. That means that 10 cubed equals 1,000. So the cubed root of 1,000 must be equal to 10. Our next example asks, why isn't the cubed root of 27 equal to -3? Okay, so remember, if we're going to cube a number, we're going to raise it to the third power. So -3, if I were to raise that to the third power, that means I'm going to do -3 times -3 times -3. All right, well, -3 times -3 I know is 9. And then 9 times -3 is equal to -27, which is not equal to +27. Okay, recall earlier we said that a square root can have a positive or a negative answer, but a cube root is only going to have one real number solution. Okay, so the cubed root of 27 is going to equal +3 because 3 times 3 times 3 equals 27. All right, it is only +3 and not -3. This means that we can take the cube root of negative numbers. So the cube root of -8 equals -2 is a true statement. Because again, if we take -2 and we cube it, that means -2 times -2 times -2. -2 times -2 is 4. And 4 times -2 is -8. So it is possible to do a cube root of a negative number, but you can't take the cube root of, you can't take the square root of a negative number. Let's have some practice with cube roots of negative numbers now. In the first example, we're looking for the cube root of -125. So I want to know which number multiplied by itself would equal -125. Well, I know that 5 cubed is 125. So if I were to take -5 and cube it, well, that would mean to do -5 times -5 times -5. And if we evaluate that, -5 times -5 is 25, and 25 times -5 is -125. So the cubed root of -125 has to be equal to -5. In a similar fashion, looking at the cubed root of -729, what number multiplied by itself 3 times is going to equal -729? Well, again, the cubed root of 729 is equal to 9, so let's try -9 cubed. That means we're going to do -9 times -9 times -9. If we go ahead and evaluate this now, -9 times -9 is +81. And 81 times -9 is -729. So I know that the cubed root of -729 has to be equal to -9. All right. If you remember from an earlier lesson, remember that if you cube a negative number, then the result has to be positive. Any negative number raised to an odd exponent will give you a negative number. So I knew that my answers to these had to be negative. In my last example, I'm going to figure out which two whole numbers the cubed root of 72 is in between. Okay, so I'm looking, this is similar to when we were approximating square roots. We're going to do the same thing there. We look for the first perfect square less and the first perfect square more than the number underneath of the square root symbol. Here, I'm going to look for the first perfect cube that's less than 72 and the first perfect cube that's more than 72, so that when I take the cube roots, I'll know which two whole numbers I'm going to be in between. Okay, so I'm going to have my cube root of 72. That's going to have to be between two perfect cubes. Well, the first perfect cube less than 72 is 64, and the first perfect cube more than 72 is 125. So if I were to take the cube roots of those numbers, then the cube root of 72 is going to have to be between those because 72 is between 64 and 125. So if I evaluate the cubed root of 64, that equals 4. 4 times 4 times 4 is 64. And the cubed root of 125 is 5. 5 times 5 times 5 is 125. So the cubed root of 72
must be somewhere between 4 and 5.